Welcome to Chemistry Prep Station 2025. In today's class, we're going to look at acid, bases, and salts. And at the end of the lesson, you should be able to define acids, list the characteristics of acids, list the method of preparation of acids, then list the uses of acid. All right, let's start. So what is an acid? An acid is a substance which produces hydrogen ions or a proton as the only positive ion when dissolved in water. This process is known as ionization. For example, if you dissolve HCl acid in water, you're going to give us what? H plus and Cl what? Minus. So the presence of this H plus makes this compound an acid. You also have an example, let's say H2SO4. So when this compound is ionized, you're going to have H plus and SO4, 2 minus. So you must balance by adding what? 2 moles in front to balance what? The H of the present in the H2SO4. So we have other examples of this. So whenever a substance dissolves in water, okay, and you give you H plus as the only what? Positive ion, that compound is an acid. All right, we have classes of acid. The 2 major classes of acid are organic acid and what? And inorganic acid. From the word organic, organic means natural products. So these are acids that are obtained from naturally from plants, from animals, example, ethanoic acid, whereas the inorganic are man-made acid. Okay, prepared from mineral elements, example, HCl, H2, SO4. All right, let's look at the strength of an acid. Strength means the ability of this acid to do what? To lose its proton is called the strength of an acid. That takes us to the 2 types of acid that we have, which is what? The strong acid and also what? The weak acid. Now, what are strong acids? Strong acids are compounds that ionizes completely in water in aqueous solution to give us what? To give us a high concentration of hydrogen ion. Don't forget this. Okay, give us having a high concentration what? Of hydrogen ion. Don't forget that the presence of H plus make this what? An acid. Okay, so the weak acid is the opposite of what? Of a strong acid. That do what? They ionize incompletely in water, partially or incompletely in what? In water. That means that we're going to have what? A low concentration of what? Of the hydrogen ion if that compound is what? Is a weak what? Acid. For example, these are all examples of what? Of strong acids. Some example, sulfuric acid, okay, hydrochloric acid, nitric acid. What of the weak acids? Example, the citric acid, malic acid, what? And ethanoic acid. Okay, so let's continue. Okay, these are the sources of the inorganic acid. For example, we obtain acetic acid from vinegar. All right, we obtain the malic acid from apple. Then the lactic acid is from milk. All right, then we have the formic acid from ants, then tartaric acid from grapes, oxalic acids from tomato, and lemon as well give us what? The citric acid. Okay, that's a cause what we call the basicity of an acid. What does that mean? It means what? There is a number of hydrogen ions, okay, present right, in a molecule of an acid. So whenever an acid ionizes, dissociates when dissolved in water. Now the presence of this, okay, how many of the ions are present in that acid is called what? The basicity of that acid. For example, we have what we call the mono acid, okay, the dibasic, we have the tribasic. In the case of mono acid, we have HCl. For example, if HCl ionizes in water, they're going to give us what? Only one, okay, proton, which is the hydrogen ion. All right, with the Cl what? Minus. Now, if a compound is a dibasic, means that when a compound is dissociated in water, what will you have? You're going to have what? 2 H plus. So the presence of this H plus, okay, being 2 in this acid means what? A di. Don't forget that mono means 1, di means 2, tri means 3, tetra means 4, and so on. So we also have what we call the tribasic, tetrabasic, and so on and so forth. So the ability, okay, the number of hydrogen ions present in an acid is called what? Basicity of an acid. For example, these are all examples. HCl is monobasic acid. H2SO4 is what? Is dibasic. This one is monobasic also because of what? This one contains just one hydrogen atom, give us a monobasic. This one is tribasic because of what? The presence of H3. This one is also what? Monobasic. In this one case, you're going to have CH3, all right, COOH minus plus H. So this is what makes it what? A monobasic what? Acid, and so on and so forth. All right, let's proceed. So what are the physical properties of acid? One, acid turns blue litmus paper red, in which you know, all right? They have sour taste, example, sour taste of unripe fruit, means that most of the unripe fruits contains what? Contains acid, but they are mostly organic acid because they are edible what? Acid. Strong acids are corrosive in concentrated form. Example, HCl, H2SO4. They are strong what? Electrolytes. All right, well, so what are the chemical properties of acid? I'm going to give you the three major chemical properties of acid, which is what? First one is reaction with metal. So when an acid reacts with a metal, okay, a salt is always formed. For example, this is a metal, okay, magnesium, reacting with what? With tetraoxosulfate 6 acid. Now, the magnesium replaces what? The hydrogen and give us what? Magnesium tetraoxosulfate acid with what? With the release of an hydrogen gas. So a salt is formed in this regard. So whenever an acid reacts with what? With a metal, a salt is always formed with the release of what? Release of hydrogen gas. The number two most important reaction of acid is what? Reaction with what? Bases and so on. For example, the base dissolves in an acid and neutralizes it. So also a salt is formed. So this process is called what? Neutralization reaction. Okay? Whereby an acid reacts with a base, all right, and form what? A salt with water as a byproduct. So the whole of this process is called what? Neutralization what? Reaction. Okay, now the third reaction that is very important is called reaction with carbonates. And what is always produced here is what? A CO2 gas is always released at the end of this reaction. Okay, for example, HCl reacts with what? With a what? With a carbonate. This is called calcium trioxocarbonate 4. Reacting with what? HCl give us what? Calcium chloride, water, and CO2 gas. So CO2 gas is always evolved whenever carbonate 4 ion reacts with what? With an acid. Okay, let's proceed. Uses of acid. We have many uses of acid. I'll give you just few. For example, sulfuric acid is used in what? In making paper, okay, paints, detergents, fertilizers. Then nitric acid for what? Fertilizers, rubber, and what? And plastic. What about hydrochloric acid? Okay, separate metals from all digestion, keeping swimming pools free of algae. Then citric acid, okay, are obtained from vitamin C. Example found in orange and most of other fruits that we have. Then what about citric acid? Is found in vinegar and so on. So this one is used mostly if you open minerals. So you see some white fizzles from fume coming out from what? From your mineral. So that acid you see there is what? Is called carbonated drink. Okay, gotten from where? From what? A carbonic compound. This is an inorganic what? Compound. So a acid what? Is present. All right, so let's look at, okay, this is a classwork. All right, from what we have learned so far, define acid your own way. Okay, then differentiate between strong acids and what? Concentrated acid. Then what is basicity of an acid? Take your time to look at this. Okay, look at how we can prepare acid in what? In the laboratory. We next move towards the base. So in this regard, we're going to look at how can we define base, properties of base, method of preparation, and also what? Uses of base. All right, so what is a base? A base is a substance that donates hydroxide ion when dissolved in water. For example, if a compound is a base, it must always contain OH. And this is your what? This is your hydroxide ion. So whenever a compound is a base dissolved in water, an hydroxide is always what? Produced, okay? It donates out. All right, that is why they are always combined to neutralize an acid to form what? Water at the end of the product. Okay, no. So these are examples of some bases that we have. For example, sodium oxide, zinc oxide, copper 2 oxide, magnesium hydroxide, aluminum hydroxide. All right. So if a base also contains what? Contains oxygen. That's why we call them basic oxide. Example, zinc oxide, copper oxide, and so on and so forth. We have many other examples of what bases. And don't forget that not all alkalis are bases. Now, if a base dissolves in water completely, that base is known as what? An alkali. Okay, so that means that not all bases can dissolve in water, but all alkalis and the what can dissolve in water. In other words, a soluble base is known as what? Alkali. All right? Most bases are insoluble. However, some bases are soluble. So what are examples of alkali? For example, these are typical example, okay, of bases that can dissolve in water. Sodium hydroxide can dissolve anytime, any moment. What of potassium hydroxide? Yes, it can dissolve. But this one will give us a partial dissolution in water. In the likes of copper 2 oxide, zinc oxide, magnesium hydroxide, iron 3 oxide. Okay, these are all what? Bases that will not completely dissolve in water. But alkali will give us a complete clear solution when you dissolve them in water. So these are examples of bases and alkali and their differences. All right, so let's proceed. So what are the properties of bases? Bases are soapy to touch. The main reactant or the main content of soap that we normally use is what we call the caustic soda. That's why if you use soap to bathe or wash your clothes, it always will feel soapy because of what? The basic content. Then some soap also contain potassium hydroxide. So these are the major chemical used in producing soap. All right. So they have bitter taste. Example, lime water. What is lime water? Lime water is simply calcium hydroxide. That is the alphabet name of lime water. So it's a base. They turn red litmus paper blue, opposite of what? Of acid. Then also, concentrated form of the caustic soda of alkalis are what? Are highly corrosive. Note, concentrated form, not diluted. All right, let's proceed. All right, this photo shows you an illustration what happens when a compound is a base and an acid. I said before that a base will turn what? A base will turn red litmus paper blue. So this compound is a base. When you insert into acid, what happens? It changes the color from what? From red to blue. So the same is opposite to what? To acid. Acid will change a blue litmus paper to what? To red. Don't forget, these are the most simple illustration of what? Of acid and base. And these are other indicators and their color changes to show whether a compound is a base or an acid. Okay, so let's move on. Chemical properties of alkalis. First, they react with acid to produce salt and water only. For example, this is copper 2 oxide is a base, all right, reacting with what? With an acid, H2SO4. What is formed here is what? Is a salt. And this salt is a normal salt because it has no hydrogen atom in between. With the release of what? Release of water as a byproduct. So, and this process is known as what? Neutralization reaction. So all alkalis do what? Undergo the same process. Reacting with an acid to give us what? Salt and water. Another example, this one is very common. Okay, this is a hydrochloric acid. Reacting with what? With sodium hydroxide. That gives us what? Our common salt that we eat. This is a common salt called sodium chloride, all right? And water. So whenever a base reacts with an acid and it produces salt and water, that process is known as what? Neutralization reaction. Okay, another common property of alkalis is that it reacts with ammonium salt, okay, to liberate what? Ammonium gas. For example, this is ammonium chloride or ammonium compound with the base What is formed here is what? Is a normal salt, NaCl, water, and ammonium gas is evolved. So whenever this process happen, that means that a base, ammonium salt, is what? Reacting with a base to give us what? Ammonium gas, all right? And water as a byproduct. Okay, so let's take a brief break. We'll come back and continue from where we stopped. Thank you.